Okay, hello everyone. Again, we are here to continue lesson 5.2. Uh, we are we still have the part that is like about solving problems. So far, we learned that force of friction equal mu times Fn, where Ff is the force of friction, mu is called the coefficient of friction, Fn is the normal force. Now, if the object is not moving, then the force of friction is static and it's Fs max equal mu s times Fn. And if the object is moving, then the force of friction is kinetic and Fk equals mu k times Fn. As I told you that Fk is always less than or equal Fs max, and since Fk is less than Fs max and Fn the same, so of course mu k will be also less than or equal to mu s. Now, to solve problems, I would recommend to follow the following steps or tips. The first tip is to draw a free body diagram. Free body diagram is a like a rough sketch for the object on the surface with all the forces acting on this object. Let's say here I have a box here, and there is someone pushing this box. The forces acting are Fg, pointing always vertically downward. Fn is the normal force. Remember that Fn is always perpendicular to the surface because it's the force exerted by the surface on the box. The person is exerting a force of push or force applied. If applied, let's say the object is not moving, then the opposite force is force of static friction. Second, Fs or Fk is drawn parallel to the surface. As you see here, Fs or Fk always has to be drawn parallel to the surface and in opposite direction to the motion. This is the, let's say, the opposite direction of motion. Fs is in the opposite direction. Third step or third tip is to apply Newton's second law. So always whenever we want to solve problems, we will start by applying Newton's second law. Newton's second law states that the net force equals the mass times the acceleration. F net equal m times a. F net here is the sum of all forces acting on this object. M is the mass, has to be in kilograms, and a is the acceleration, meter per second squared. Now, for acceleration, if we give a definition for acceleration, acceleration is defined as the change in velocity over a period of time. So if the velocity is not changing, then there is no acceleration. Which are the cases, or when are the cases that velocity is not changing? There are two cases when velocity is not changing. The first one is when the object is at rest. When the object is at rest, then it's not moving at all. So there is no change in velocity, and therefore there is no acceleration. And the second case is when the object is moving at constant velocity. Constant velocity means the velocity is not changing. So there is no change in velocity, therefore zero acceleration. In this case, zero acceleration if a equal to 0 times m equal to 0. So F net is equal to 0. But if the object is accelerating, then acceleration is not equal to 0. And in this case, F net is equal to m times a. Okay, so this is for the acceleration. Now F net, how can I find F net? So as we said that F net is the sum of all forces. Like the case here. It's straight. And the box. Now, the forces acting are Fg, Fn, F applied, and Let's say Fs. Here, when I say sum of all forces, I have to take one direction or one dimension at a time, the horizontal and the vertical. So, since I have the motion or the possible motion that will occur is or will be along the horizontal direction. Okay, so the motion will be either, or it will be in this direction if there will be a motion. Okay, so when I say sum of all forces, I say sum of all forces along that are acting. Let me write this. Sum of all forces that are acting along the horizontal. Along the horizontal. And in this case, the horizontal forces or the forces acting along the horizontal are F applied and Fs. Okay, so because F applied and Fs are in opposite directions, so remember to find the resultant for two forces or two vectors that are pointing in opposite directions, what do? Yes, we subtract their magnitude. So F net in this case is equal to F applied minus Fs. Okay, so always we start with the force that is in the direction of motion, because I'm assuming here the direction of motion is the positive direction. This is the positive direction. So F applied is in the positive direction, Fs in the negative direction. So F applied minus Fs. Then, and also we know that F net is equal to, in this case there is no motion, equal to 0. No motion. It's Fs. Okay, static friction. The object is static. F net equal to 0. So here I can replace F net by those two. So F net, well, it's equal to F applied minus Fs. I can replace this here. So this equation becomes, instead of writing F net equal to 0, I can write F applied minus Fs equal to 0. Okay, this equation, this is like we can take this as a first equation. This is one equation. All right. Now we shouldn't forget about the y direction or the vertical direction. Since there is no motion along the y, since no motion along the vertical, along the y direction, then the forces cancel each other. So what does it mean? Opposite forces cancel each other. Here I should add opposite forces. Opposite forces cancel each other. In this case, Fg is equal to, not the other way, N is equal to Fg, and you have to remember always that Fg is equal to M times G. You should never forget this, where G, what is G? Yeah, it's acceleration due to gravity. 9.8 meters per second. Okay, and M is mass, kilograms. So those are the two equations that we have to use in solving problems. This is the first, and this is the second. This is 1, and this is 2. Okay, we combine them together to find F applied. Also, along with those two, we shouldn't forget the equation for Fs. equal mu s times Fn. And this is the third equation. Number 2. So we toggle between those three equations. Those are the three equations that we will use in any problem. Now, if there is motion, then Fs is replaced by Fk. This is one. Two, Fnet is not equal to 0 anymore. It will be equal to m times a. Let's see this example. Let's solve this example. Example 1. You need to move a 105 kilogram sofa to a different location in the room. It takes a 403 Newton force to start the sofa moving. What is the coefficient of static friction between the sofa and the carpet? So you need to move a 105 kilogram sofa. So this is the mass of the sofa and equal 105 kilograms. You have to move to a different location in the room. It takes a 403 Newton force. So what is this force? Yes, it is the force that we need to apply on the sofa to move it. So this is F applied equal 100 to 403. Yeah. To start the sofa moving, what is the coefficient of static friction? Coefficient of static friction. Okay. So what do we have to find here? Coefficient of static friction, which is US. That's right. Okay, what is, how can I find Vs? What is the equation that gives me the coefficient of static friction? Yes, mu s is equal to Fs over Fn. Okay, so to find Fs and mu s, I need to find, or I need to know Fs and Fn. Okay, do I have them given in the question? Apparently it's not. Fs, it's not there. I have mass, I have applied. Fn also, it's not there. To solve problems, as I told you, that the first step that we have to do is to draw a free body diagram. Free body diagram, put the object on the surface, okay, and draw the forces acting on this object. So what are the forces acting here? Always force of gravity acting downward is Fg. Normal force, opposite, Fn. I have the applied force, let's say it's applying the force to the right, and force of friction. What type of friction do we have here? Static or kinetic? Since they are asking for the coefficient of static friction, then the force of friction is static, and of course it has to be opposite to the applied force. It has to be equal in size. So this is this. Okay. So this is for the given. Second, to start solving, I start with the Newton's second law. The Newton's second law. F net equal m times e. Okay. Do I have acceleration here? Of course not. I'm talking about static friction, so the object is not moving. Then a equal to 0. No motion. So this equation will be F net equal to 0. Now we have to find the forces or the net force acting along the horizontal. The force along the horizontal are F applied and Fs. So F net here is the sum of those two forces, but because they are in opposite directions, then F net is F applied minus Fs, and it's still equal to 0. If I move Fs to the other side, this equation will become F applied is equal to Fs. Okay, what do you notice here? You notice that this quantity Fs is found here because F applied is known. So Fs is equal to F applied, which is 403. The first quantity is found. We still have Fn. How can I find Fn? So as you see here, that the object, there is no motion along the vertical direction. So this means that the upward force is equal to the downward force. And it's actually the case in most of the, or it's always Fn equal to Fg in most of the cases. So Fn is equal to Fg, and Fg is equal to m times g. I have the mass, you can plug it here. So it's 105 times 9.8, which is the g. So in this way, I got Fn. So Fn is equal to 105 times 9.8 gives 1029 Newton. Okay, so now I can find US. Now I get back to this formula. US is equal to Fs over Fn. So it's 403 over 1029. US is 0.39, approximately 0.4. What's the unit? Newton? No. No unit. Remember that unit has a so we applied Newton's second law. We applied the equations along the y and the equation for the coefficient of static friction. All those equations together, 1, 2, and 3, like lead to find whatever the quantity that we need to find. All right.